This lesson is on the slopes of lines. The slope of a line is a measure of how steep it is. The formula that defines the slope of a line is slope equals rise divided by run, rise over run. The rise is how much vertical change in length there is over a defined line segment, and the run is how much horizontal change in length there is over a defined line segment. If we think about things in reality, in our real world that have a slope, you can think of the side of a mountain, the side of a hill. The steeper the hill is, or mountain is, the larger its slope will be. And the less steep it is, the less its slope will be. Let's look at some examples. Example 1. What is the slope of the line segment below? So slope equals rise divided by run. When counting, always go from left to right for the entire question, or from right to left for the entire question, but you got to stick with one. Either left to right for entire question or right to left for entire question. So for the rise, let's count how many squares that the endpoints change in height from left to right. So there are clearly defined endpoints here that hit the grid, and going from left to right is what I'm going to choose as the convention for answering this question. We have from here to here, how many grids does it go up? 1, 2, 3, 4 is how many it increases, positive 4. So that is our rise. And our run is how many squares that the endpoints change in horizontal direction. Again, from left to right, that's what we chose. So from left to right, we go 1, 2. So it's positive 2 is the run. And then we just plug that into our formula. And we have positive 4 divided by positive 2, and that equals a positive 2. So our slope equals 2. Example 2. What is the slope of the line segment below? So again, we have clearly defined endpoints here. They're hitting intersections of the grid. Slope is rise over run. When counting again, always go from left to right for entire question or right to left, so I typically go left to right. So for the rise, count how many squares the endpoints change in height from left to right. So from here to here, it is a rise of plus 1. For the run, count how many squares that the endpoints change in horizontal direction. So from this endpoint to this endpoint, it's 1, 2, 3. 3 is our run. And so the slope is the rise, positive 1, divided by the run, which is positive 3. So our slope is 1/3. Example 3. What is the slope of the line segment below? So again, we have clearly defined endpoints. Slope is rise over run. Again, when counting, go from left to right or right to left for entire question. So for the rise, count how many we go up. So let's go from left to right, and now we're going to actually have a negative rise. So from here to here, we're going down. Down means negative, up means positive. So down 1, 2, 3. So negative 3 is our rise. And for the run, from left to right, it's 1, 2 in the right direction. That's the positive direction. So our run is positive 2. So the slope is rise over run. Rise is negative 3. Run is 2. And so our slope is negative 3 divided by 2. Let's look at parallel slopes now. The slope of two parallel lines are equal to each other. These two lines here have the same slope. I'll prove that to you. What is the slope of the line on the left? Well, the slope is rise over run. The rise is 4, the run is positive 4, so the slope is 1. What is the slope of the line on the right? Well, you'll see if you find out the rise and the run, it is the same, 4 over 4, which is 1. So remember that now. The slope of parallel lines is the same. Let's look at perpendicular slopes now. So we have a line segment here, and then I've drawn another line segment here that is perpendicular to the first line segment. Remember, that little square means perpendicular. What is the slope of the line on the left? Well, the slope is rise over run, so we have going from left to right, 1, 2, 3, 4, 5, 6, positive 6, and then the run is positive 2. So our slope is 6 divided by 2, which is 3. What is the slope of the line on the right? The slope is, our rise is going down, so it's a negative 2, and our run is a positive 6, so negative 2 divided by 6, which equals negative 1 over 3. When you reduce that fraction, divide 2 into both the numerator and denominator. So we can see a rule here for the slopes of two lines that are perpendicular to each other. It is that they are called negative reciprocals of each other. So from the example shown here, the slope of one line is positive 3 and the slope of the other is negative 1/3. So what is a negative reciprocal? You take the reciprocal of the first number, so it was positive 3, and then it'll become 1/3, and then it's the negative reciprocal, so you just add a negative sign, or the opposite sign rather. So if this started as negative 3, you would get positive 1/3 here. But we started with a positive 3, so you take the other sign, negative, and you take the reciprocal. And that was proven over here with one example, and it is the case always when two lines are perpendicular to each other for slopes. This is a very important one to remember. The parallel slopes being the same, you can figure that out pretty quickly on your own, but perpendicular slopes being negative reciprocals. Remember that term negative reciprocal for a perpendicular slope, and you'll be set for a bunch of questions that bring that up. Example 4, what is the slope of a line perpendicular to the line segment shown below? So the slope of the given line segment is negative 10 is the rise, and positive 2 is the run. So our slope is negative 5 for this line segment. Now instead of trying to draw a line perpendicular to the given line segment and then determining its slope, please just memorize the rule that we found out on the previous slide. The negative reciprocal of this negative 5 will give us the slope of a line perpendicular to this line. We don't even need to draw that line. So the negative reciprocal of negative 5 is positive 1/5. Again, take the reciprocal of the number 1/5 and then change the sign. So the slope of the line perpendicular to the line segment shown is positive 1/5. Example 5, what is the slope of a line perpendicular to the line segment shown below? So we'll do the same thing we did in example 4. The slope of the given line segment is plus 12 over plus 10. If you count our rise from left to right, we're going up, so that's positive, and it's 12 squares there. And then our run, we're going left to right, so that's positive, and that's positive 10. So that's 12 divided by 10, reducing that, dividing 2 into each of those numbers, we get 6/5. And so, again, let's just use the rule we just learned, instead of trying to draw a perpendicular line to this segment. The negative reciprocal of positive 6/5 is negative 5/6. So again, take the reciprocal, you flip that fraction, and you change the sign from positive to negative. So the slope of a line perpendicular to the line segment shown is negative 5/6. And that's the end of that lesson.